All right, let's get started. Um, sorry, I'm recovering from a cold. I'm like 90% there. I just have a yeah, but just bear with me for this lecture. Um, all right, so for this lecture, we're gonna talk about some more Swift things, some more Swift techniques, and we're gonna talk about actually building UI using Swift UI. So this is one of my favorite lectures of the semester because you guys will actually now know how to build UI, which is really cool. All right, so announcements. For those who don't know, iOS 26 and all adjacent releases are released today, theoretically. So I think you just go to settings and you could see, I don't know if they released it just yet, but you could just go to settings and download the new stuff. But of course, this is point 0, so there might be some still bugs or whatever. So if you want to be more on the safe side, maybe wait until like the point 1 released or something. But now you know. Um, we won't be counting attendance for this first week because it was the first week. Some people were still trickling in or joining the decal, so we're not going to be counting against that. But we will for this week. Just a reminder that the discussions are mandatory, and the discussion one assignment is due this Friday by discussion. I'm going to check you off in discussion, and please utilize Ed if you have any questions or come to office hours if you need help, which is right after this. Um, Discussion two, we're gonna basically now move to a Friday schedule for discussion assignments. So we're gonna release this discussion assignment on Friday, and then it's due the next Friday. So yeah, we're gonna release the discussion two assignment this Friday. So all you need to do right now is just to focus on the discussion one assignment. All right. Any questions about logistics? It's good. Okay. All right. So here's the agenda for today. We're going to talk about something called optionals, which, if you have done something called Rust before, it should look pretty familiar. We're going to talk about what is object-oriented programming. Hopefully, you have utilized object-oriented programming in the past. We're going to talk about something called structs versus classes. So there's are two ways that we can create objects or instances. And we're going to talk about the differences of when you use structs versus classes. And then we're going to talk about some fundamental SwiftUI basics of what is SwiftUI, what is the philosophy of SwiftUI, and how would you use SwiftUI to create UI. And then I'm going to do a demo about creating a UI in SwiftUI. All right. So um, we're going to review what we talked about when we near the end of last lecture, which was something called enumerations. And enumerations basically declare a common type for a group of related discrete values. So usually it's for things that could be represented by a list of discrete cases. So when I want to present something that's finite or has many different cases like matter, state of matter, or direction, or cardinal directions, an enum is a great way to kind of encapsulate those different cases together. Um, a a optional is a enumeration with two cases, some with some wrapped value and none. Okay. So what does that mean? Well, optionals are just enums. It either has a value or it doesn't. Okay. So I think if you've taken 61A before, this none case is sort of like none in Python. Or in Java in 61B, it is this nil. We call it nil in Swift, but it's analogous to none in Python and null in Java. So here we have a variable called optional string one, and its type is not just a string anymore. It has a string question mark. And what this type it's an optional string. Call this an optional string. And we assign this case to the value of nil, right? But in this case, it's still the same. It's a different variable, but still an optional string. But the value assigned to it is an actual string. So as you can see here, there's again just two cases. An optional of a type has value or it doesn't. Okay, and we represent this doesn't with a nil. So to declare an optional, you use or you append a question mark after the type declaration. So here's an analogy. I have a variable called optional int, and its type is, oh yeah, it's an optional int. And I'm going to print it out. So I'm going to use this function called type of. I'm going to pass the variable in. And what's going to print out is optional. And then in these caret or whatever these things are called, the value is a type is int. So you can see the value of the variable is wrapped around this optional construct. So we could think of this like a present. Okay. So the present itself, right, is the variable itself. It's optional int. And inside of this present is the value. In this case, it's nil. And we call the thing, the value within this present, the wrapped value. So, okay, in this case, now we assign the value 5 to the optional int. And we try to increment, or sorry, we try to add 10 to this optional int, which is 5. But when you try to do this, Xcode is going to yell at you and says, the value of optional type int question mark must be unwrapped to a value of type int. And the reason is because we can't do arithmetic operations on an optional because, again, the value is wrapped in that optional. We need to unwrap it. We need to take it out. So how do we do that? So again, here is what we had just before, right? It's the 5 is within this present. It's wrapped in this optional. We want to take it out. We want to get it out. So there's a couple ways we could do this. Again, we want to get the 5 out. And once we do that, the value of that 5 is just the regular int. So we could actually do operations on it. Okay, there's a couple ways we could do this. One of them is called optional binding. And so what we do is that we use an if statement to conditionally bind the wrapped value of an optional to a new variable. And if there is something in optional, if it's not nil, we conditionally assign it to the new variable, and we could use it within the if closure. Sorry, not if curly brackets. Okay, we haven't done closures just yet, but here we have a variable called optional string, right? And it's actually assigned to some value. In this case, hello world. And here we have this kind of if else statement to kind of look like. And here in this if statement, right, this condition, what we're trying to do is that we're trying to get the wrapped value from this optional out. And so what this if let, right, this if let does right here is that we're saying, does optional string have a value? If it has a value, we unwrap it and we assign it to this variable called unwrapped string, which is a new variable that we could use within this context right here, within these brackets, curly brackets. If optional string is nil, that means there's no value. We just jump to the else case. So this way, we could safely access the wrapped value within the curly braces here that we could use. Okay, this is called optional binding because we're binding this value to a variable. Another way is something called optional chaining. And this is one we use to safely access properties or methods of an optional instance. So here is a dictionary. Okay, so the dictionary is called image paths. Remember, a dictionary takes in a key and it outputs a value. Now, what's really weird is that Swift dictionaries, when you try to access a value via its key, it'll return an optional. Like in Python, when we do this, it will just give you the value or it just gives you nil. But in this case, it will give you an optional something. So in this case, we try to get the value associated to the key star. That returns an optional string. In case our dictionary right now is key is a type string and value is a type string. So it returns an optional string. And we want to call this method called has suffix. Does this string has a suffix.png? If it's true, we basically print this statement out, right? So what happens if this is nil, right? What happens if there is no value associated to this key? Then it will just basically skip and just continue onwards. So this is really safe to kind of interact with in accessing properties or methods of an optional instance. Okay. So yeah, image paths star returns an optional. If it's not nil, we continue onwards, else we just go to the next stuff in the code. Okay, next is something called the nil coalescing operator. And it's basically where you could specify a default value if the optional object is nil. So in this case, we have our image paths dictionary. Right now, it's an empty dictionary. There's nothing in it. We have a string called default image path. And here we have this variable called part path. Right now, right here, I'm accessing the value associated to the key part. Now, this again, this is optional. It could be nil. So let's say I want to supply a default value that if it is nil, we use this value instead. So if this is nil, we use this default image path. If it's not nil, we use it as it is and continue. Okay, so this is another kind of way of dealing with optionals. All right. The final way of working with the optionals is something called unconditional unwrapping, or aka force unwrapping. So sometimes you know that an optional variable always contains a value. And so you can use something called an exclamation mark to force unwrap it. So here we have, again, some similar code with this image paths dictionary. And here we have, again, this thing can return optional. But let's say, in this case, now we're not using a question mark anymore. Now we're using an exclamation mark. And what that means is I don't care what value is in there. I want to get it. Now, right now, this code is going to crash. It's going to crash your app. Why? Well, because there's nothing in the dictionary right now. There's nothing in it. So there's nothing associated to the key of star. So when we run this, it's going to blow up. It's like, okay, I can't call has suffix on a nil. So this is going to trigger a runtime error, and your app is going to crash, which is not good. Finally, with working with optionals, there's another, I like to use this a lot. It's something called a guard statement. So what it does is that, let's say we have this function here, it's called transform, and I want to do some operation on this passed in string. So I pass this string in, I'm going to do some action on it. I want to do this action if the string has a minimum length of required min length. So here in this guard statement, it's sort of like an if else, okay? But you think of like a door, okay? So it says guard, this condition, s.count, which is the length of the string, is the length of the string greater than or equal to required min length? If it is true, we continue onwards. If it's false, we catch it in this else block right here, and we have to return something out. In this case, this function returns a string, so we return an empty string. So this is a better way of using an if-else, because it kind of maintains, because if-else, you're indenting the code, sometimes get messy. This is syntactically, I think, a better option because it just keeps everything aligned, right? And it's very simple, right? This is like a door. If it's true, I'll let you go through. If it's false, we're going to hold you back, okay? So, yeah, use guards whenever you find yourself using if-else a lot. Okay. I know that was a lot, but optionals play, I think, a huge role in Swift. Let's say, for example, you're making a game, and one of the properties is like, who won the game, right? Well, we don't know yet, right? We don't know who won the game just yet. So maybe you have a variable that you're keeping track of that has of type optional to player object, right? So this is a great way of trying to keep, encoding that kind of nothingness in your code. All right, so that's optionals. And once you kind of go through them or, use a bit more, you get more comfortable using those. Any questions so far? Does that kind of make sense? Yeah, question. Yeah, so the question was, could you go over guard again? So yeah, so a guard statement is sort of like an if-else. You could rewrite this as an if-else, right? So what this guard statement does is that it takes a condition and it checks to see if this condition is true or false. So if this condition is true, we continue. So if this condition is true, we continue onwards with the rest of the function. If this is false, the guard blocks you and we run the else case instead. So you could rewrite this saying, if s.count is greater than or equal to required min length, do all this, else return any string. It's the same thing. But syntactically, there's a different way to write it, and I think it just makes a lot more sense because as you read it, it's like, oh, is this true? Okay, it's true. Continue, continue, continue. If it's false, exit or do whatever it's in here. Okay, does it answer? Yeah, good question. Yes. Question was, why was it better than if? Um, fun Functionally, it's the same thing, but because an if else, like syntactically, you have to indent your code, right? Um, and but here it just kind of maintains the flow, right? You don't need to indent anything. It's just kind of like this on the similar, like same hierarchy. It just syntactically, I think it looks better, but functionally it's the same thing. Yeah, good question. Any other questions? Okay, cool. All right. I want to go to object-oriented programming. So, how many guys heard of object-oriented programming? Okay, most of you. So, object-oriented programming is a programming paradigm that organizes code into objects that help encapsulate data and behavior. And what it does is it allows your code to be more modular, reusable, and easier to maintain later on. And so, let's take a look at modeling a person, right? So currently, with our knowledge, let's say we want to represent a person in code with these four different properties: name, age, occupation, and favorite color. Now, currently with our tool set, we could do this via four variables, right? We could create four variables of all these different properties and associate to that one person, right? Now, let's say we want to model a school. You could think of a school has a lot of people in it. So, well, we have to, if school has, for example, a high school of 2,000 people, we have to have 8,000 variables. That's terrible. That's hard to kind of manage and like things get wrong. So to do this, we have something we could use called a class. So a class and a struct. But um, in code, we can represent, okay, in Swift, in this case, we represent it using something called a struct. And for right now, you can think of a struct and a class sort of the same thing. There's some differences, which I mentioned later, but right now you can think of the same thing. But again, this is sort of like encapsulating all of these properties and attributes into a single entity called person, right? And yeah, name is a string, age is an integer, occupation is a string, and so forth. So this struct, what this does is sort of like a blueprint. So if you haven't heard what a blueprint is, simply like you could take this blueprint and you can create multiple things of it, right? When you build a house, usually the construction company has a blueprint that tells how do you build a house. And then you can take this blueprint to somewhere else and do the exact same thing and construct the exact same house somewhere else. Okay. So it's a blueprint, and we can create objects from this blueprint. And that action of creating objects from a blueprint is called instantiating. So here we created two people, and we call these instances or objects of the person struct. So we use this blueprint, right? And we create these two people. And these two people have different values for the properties, right? Kaylee, her name is different from Robert's name, right? The age is different, and so forth. And we could use these objects in our code to do operations. And so this is how it looks like in Swift. So to create Kaylee, you would do something like person, and then in parentheses, you pass those values in there. And I can access values or these properties using dot notation. So I do Kaylee.age, and I get 35. If you want the color, I do Kaylee.favorite color. But there's also classes, right? You might heard in other languages, you would use class like Java instead of struct. So let's talk about the differences between structs and classes. So this is how you would declare this person with a struct. Here's what you do with a class in Swift. So one of the main differences is that you have to declare an initializer, whereas a struct has one built in. So both can define properties to store values. Both you could have methods inside of them. Methods are basically functions within a struct or a class. Properties are basically variables within a struct or a class. Um, you don't need to worry about this, but what's cool is in Swift is that you can have subscript notation. So remember how we can index into a variable and we use that bracket? Well, you can do the same thing for a struct or a class or object. This is really cool. But again, um, you can define initializers if you want, and you can extend them to expand their functionality. Uh, you can conform to protocols. I mean, don't worry about this if this doesn't make any sense to you. Protocols are basically like how many guys take in 61B? Um, they're interfaces in Java. Okay, so they're basically a basically kind of a declaration of the methods that this thing, whoever conforms to this, can implement them. But again, don't worry about this. Um, but the main thing is that classes have inheritance. So if you want to inherit something, you have to use a class. You could typecast a class into another class. There's deinitializers so that when the object is removed from memory, you can actually do callbacks on them. Classes use something called reference counting. So again, don't worry about what any of this means if this doesn't make sense to you, but basically classes, they're references. So they live on the heap. And what this means is that the computer has to, or the program or compiler has to keep track of all of the class instances that are being created. And so basically we use this technique called reference counting, which basically says each object keeps track of whoever is pointing to that object. If an object has no one pointing to it, well, then we could basically remove it from or delete it from memory, right? This is a different method or different um, kind of method of it's like garbage collection basically in Java, but this is a different way. And so what this means is that classes are more structs are more lightweight than classes because classes have all this kind of stuff and has arc. Um, they're more performance heavy. So Apple suggests you to use structs whenever possible than classes. Some important difference is that structs have a default member-wise initializer, so I don't need to provide a init method. Structs are value types. So what that means is that, so this is the biggest thing. There's a concept between value types and reference types. When you assign a variable, when you assign a struct instance to another variable, the data gets copied. Or when you pass a struct object to a function, it gets copied. Whereas a class, since they're reference, they conform to reference semantics, you're passing a reference. So for a class, you're actually passing like an address. So each class, you can think of it as like an address, right? And you're passing that address around. And then you could later in your code, that piece of code can refer back to your class. Yes. Um, that's a very good question. So the question was, with structs, since they get copied, couldn't get very clunky. Now, Swift has something called copy on write. What this means is that it will not copy until you actually write something to it. So Swift internally doesn't, okay, when you assign a struct object to a new variable, it doesn't copy right away. Only when the data gets written to or it's dirtied, then it actually does the copy. So it's more efficient that way. Very good question. Again, if this doesn't make sense to you, don't worry. We're just kind of getting to the the nitty-gritty details, but this value versus reference type is very important, and I'll show you an example of how it works. Now, in other languages, for example, like C, there's a concept of pointers. Well, in Swift, we don't really have a concept of pointers, so you don't think about pointers in that realm in Swift. Just don't think you don't need to worry about that. Okay. Um, okay, so this is how you would declare a person using a class, right? We need an initializer. Um, it's required for a class, but is optional for a struct, right? All right, so let's kind of recap what we just learned about values or kind of reinforce value versus reference semantics. So we have our struct person here. We create a new person called Kaylee, right? And here we're assigning Kaylee to a new variable. And on this Kaylee2, this new variable, its occupation for assigning the value of account. So what happens when I print Kaylee.occupation and Kaylee2.occupation? What will happen? Can someone tell me? What's the expected behavior of this? Yes. That's correct. Yeah. Can you explain why?
Because it's sort by value, so you're making it up.
Perfect. Great answer. So for those who weren't able to hear, since structs are value types, when we assign a struct to another variable or new variable, the data gets copied. Okay. Again, theoretically, it doesn't get copied until here, but just right now, just think it gets copied, and then we're changing occupation on Kaylee2. That's a separate copy. So Kaylee1 is here, Kaylee is here, Kaylee2 is here. Or changing Kaylee2 occupation, this struct object. And so that's why we have two different values. All right, let's do the exact same code, but with classes now. What's the expected behavior? Yes. Correct. Can you explain why? Oh, sorry. Yes, great, good. That's right. So when we do this, right, we're not creating copies anymore. Since classes are reference types, Kaylee2 now points to Kaylee. Okay, so when we do Kaylee2.occupation equals account, we're actually changing this one right here. Okay, so there's no two separate things anymore. It's just a single thing. And Kaylee2 just points to it, and we're just mutating the original data. All right, so this is another visualization. So here's structs. We create, okay, when we do Kaylee2 equals 8 Kaylee, we create a new object. It's a copy, and we're modifying on the copy. With classes, the reference semantics, so Kaylee2 points to Kaylee, and when we do Kaylee2 occupation, what is Kaylee2? It's actually Kaylee, and we're modifying that on there. Okay, good, cool. All right, so that's structs versus classes. Again, this is kind of really important, so yeah, keep that in mind. Any questions? Good. All right, let's get to the fun part. So let's talk about SwiftUI. So I mentioned about SwiftUI last lecture. Let's review. So what is SwiftUI? SwiftUI is a UI framework. What we have been doing is Swift, which is a programming language. We don't write UI using Swift, right? We use a UI framework. So it's like React for those who have done web. Like React, it's a declarative framework. So what this means is that you simply state what your UI looks like, and you build more complex UIs via view composition. It's cross-platform, so you can target all of the platforms if you want. So we use Swift, the programming language, to control SwiftUI. So if this condition is true, show this UI, right? If it's false, do something else. There's another framework called UIKit that used to also write UI for native iOS apps. UIKit was introduced in iOS 2.0, so a while back, I think in 2008 or 2009. And it's all object-oriented. So this is how you would create a button in UIKit. UI button, dot set title, dot targets. It's very wordy. But UIKit with the imperative framework, it's step by step, right? Let's say you go to a restaurant and you ask your waiter who comes up to you, what would you like? The waiter asks you, what would you like to eat, right? And you say, if you're a UIKit in that mentality, you would say, I want you to go to that counter over there, grab the bread on the very top corner, put it, use a ladder to get it, put it down the counter, open the bread, put a knife in a peanut butter jar, get too good to, what I'm saying? It's very step by step. And I think your waiter would be they probably wouldn't like you anymore. But this is SwiftUI in this declarative philosophy. So, all right, here's a button. What should I do when I tap on it? Print something out. This is what the button looks like. That's it. So it's very simple, okay? Just tell it what you want. A very important concept in SwiftUI is that a view defines a piece of UI, okay? Each view is a UI, each UI is a view. So Apple gives us a lot of fundamental rudimentary views. So we have text, image, button, text field, shapes, and many more. And you can think of these views as like Legos. Okay. Legos, right? When you build a project, they don't just give you the whole built finished thing right to you, right? They give you basically Lego building blocks, right? That some are the same, some are different. Some Legos can do weird things, some can kind of intertwine with each other, some can snap in different places. That's the same idea here. Apple gives you all these basic Legos, and you can make more complex things using those Legos. So we could create more complex views via composing them in different ways. How do we do that? Well, we use something called containers. So here we have a text represented by this green rectangle. Now I want to put another text to the right of it or align them horizontally. We use something called an H stack. An H stack is a container that aligns its subviews horizontally. Okay. Now let's do it in the other direction. Let's do it vertically. We use a V stack. A V stack aligns its subviews vertically. Now we can actually use the third dimension, which is Z stack. A Z stack is like if you worked with Photoshop before or Illustrator, it's this axis of the string pointing to you, right? So it's like layering things on top of each other. It's like Photoshop layers. We use a Z stack to do that. Okay. Now we see, okay, so we have this text here. So to create a text in SwiftUI, we use text, and whatever the text is, the string, and there it is. Now it looks very basic, right? We know apps, right? They're beautiful. There's this text is very basic, right? So how do we actually change or style this text? We use something called view modifiers. Modifiers that modify the view. So here we use two view modifiers. One of them is called foreground style, and that basically sets the text color of this text. We want to set to this color.blue. And then we use another view modifier called bold to bold the text. And so we could basically chain these view modifiers onto each other to modify our views. Now, what's important to note is that the order in which they are matters for some applications. What this does, okay, is with this dot foreground style, it basically creates a new view using this foreground style. And then once we add this dot bold view modifier, it creates a new view, re-renders the view on top of the foreground style. So it kind of builds on top of each other. All right, so that was SwiftUI. Okay, hopefully that kind of sets you into the idea of SwiftUI. Do you have any questions about SwiftUI so far? Are we good? Okay. Okay, once you see it, it's gonna make a lot of sense. Okay, trust. If I could actually get away or exit this. Oh, okay, very good. Okay. All right, so hopefully you have open Xcode, and hopefully you have seen Xcode before, but for those who haven't, this is Xcode. This is where you would code. And let's see here. This right here, every app that you create in using a SwiftUI template, this right here, it will create this file that has this app, right? It has this app main, and it has this app right here. It has this window group. And what this really is the entry point into your app. Okay, so this app main basically specifies this is when you run the app, this is the first thing that gets run or entry point into the app. Window group basically on iPhone, just single window, but for iPad OS, you could see, some apps, they have multiple windows, so you could manage them right here. We don't have to worry about that. But here we have content view. And that's our first entry point UI. So I could right click on it. I could do jump to definition to go to this content view file. There we are. And here we have what is basically a simple view with just a text hello world. So I'm importing SwiftUI. This content view, right, conforms to this view protocol. And one of the requirements of doing so, so content view is a view, and one of the requirements is that you need to implement this body variable. What this does is that whatever is inside this body is actually what's going to be displayed. Okay. Don't worry about the sum view. Just don't worry about that. But the main thing takeaway is that whatever is inside this body is being shown. This thing right here is a macro. We're going to talk about macros later on, but what this does is not part of the code that you build onto your the simulator. This thing right here controls the SwiftUI or canvas. So next code, there's a feature called the canvas. So I could go to it by clicking this button here, selecting canvas, and I can run the canvas. And what this is going to do is that it's going to show me a preview of whatever I put within here. Okay. Again, this is only for us development purposes with the next code. Just give it a second. Sometimes it's a bit slow. And there we are. We could see our content view being shown here. And again, if I basically remove this, the thing goes away, right? This is not part of your app. This is just for development purposes with the Xcode. So let's take a look at our the bottom thing here. This is the first one is basically the interactive mode. So if there's a button, I can click on it. This one is, I don't know what's called, but it's like you can select elements. So it's selectable. So what it means is that I could select this UI here. You can see it highlights the code corresponding to that UI. This is a great way to kind of figure out where bounds are. The third one is there's different options. You could see different color scheme variants. So you could see your code in light and dark mode. You could see your code in different orientational variants. And you could also see your code in different dynamic type sizes. Here is some other device settings, and here you can specify the device that you want to see. All right, so that's a quick tour of the SwiftUI canvas. Let's actually start building some UI. We're going to build something that is sort of, I forgot to pull it up, but it's the GitHub app, and it's the Swift repository. Let me see if we could just kind of bring it up on here. I forgot to do a okay. Just give me 1 second. Let me okay. Okay, it looks a bit different because of liquid glass, but anyways, it's okay. Sorry. What? I have a lot of things going on. Okay. Cool. So, yeah, this what we're gonna create in 10 minutes, try to recreate this thing right here. All right, this header right here. All right. So what we're gonna do is we're going to let's create the logo header. So let's create this thing right here. All right. Like this. Okay, so what I like to do is I like to kind of separate things, right? I like to so one thing that we're gonna separate is this logo header right here. And another thing we're gonna separate is like this sort of main view right here. And then finally we're gonna separate this into this this main view right here. And then finally we're gonna separate this as like another thing. But like you could think of like sort of like separating to like rectangles. And again, there's many ways to do this. This is just one way. But let's start just creating this logo header right here. All right. So I could say there's two things, right? Aligned horizontally, right? This logo right here and this text. So how do I do that? What container do I need to align these things horizontally? HStack. Very good. So what we're going to do is we're going to go to HStack. All right. And right here, this is an image. I've imported an image already. You can just basically drag and drop into this assets folder, and you can reference this image via its name here, which is swift-og. So I'm going to use image swift.og. Okay. And whoa, as you see, it fills up the whole screen, right? And that's not what we want. We want to make that thing small. So we're going to make it resizable. We want it to now it's kind of fit within the dimensions of the device itself, including the safe areas. And when I say safe area is basically the areas of iOS control. So for example, this here with the notch and also here with the bottom area right here as well. All right, we're gonna set the size, the width and height of it using a frame view modifier. So I'm gonna set the frame with a width of 20 points and height of 20 points. Now, these are not pixels. In iOS, in other Apple platforms, we use the term points. Why is that? Well, starting with the iPhone 4 that introduced the Retina display. Now, a Retina display basically has each pixel or traditional pixel has 4 times the amount of pixels within that single pixel. So there's different pixel densities between different displays. So Apple unifies or simplifies it by saying points to be scalable across different displays and devices. So these are 25 points. So these are whatever you're working with, 25 points on Mac or 25 points on a non-Retina display, whatever, they kind of unify. It's the same thing. So our lovely little image is right there. Very cute. All right. So now let's now you can see it's a square. Oh my God, how do I uh sorry, give me 1 second. Let me try to figure out how do I don't want to split view though. Okay. Uh Okay, anyways. Okay, so you can see it's kind of square, but this is rounded. So to make something rounded, use something called a clip shape view modifier. And what this does is like a cookie cutter. You specify the shape, and it will basically cookie cut it or stamp it. And the shape is a rounded rectangle of corner radius of 8. And so what it's going to do is that it's going to take this rounded rectangle shape of a corner radius 8, and it's going to cookie cut it, this image. Beautiful. All right, now let's create the text. So text Swift Lang. All right. You can see the text color is a bit more grayish, so I would use something called foreground style.gray, set the gray color. Now, I could use color.gray, but it can infer that this is a color, so I can just dot gray instead. I'm gonna make the size a bit bigger, so there is a bunch of different system-wide fonts like title, large title, headline. But what I'm gonna do is I want a custom font size. So I use dot system size of 17. Okay, there we go. Cool. So that is our header. And right now you can see there's a bit of spacing here. So what I'm gonna do is that on this H stack, I could specify the alignment of this H stack and also could specify the spacing. So I'm gonna use spacing, and I want to separate these guys by 15 points. So you can see there's a bit of space there now. Okay, awesome. Cool. So let's create this the rest of the main view. So the main view is going to be the programming. It's going to be Swift, the Swift programming language, and also this link right here. Okay, so this is going to be our main view right there, right? Now, what do I do? What do I need to do next, right? So I've done here this thing so far. This thing right here is situated below it. So what container do I use now? VStack, very good. So what I could do is that I could right click on HStack, and Xcode gives me an option to embed in a VStack. So I click on it, and now it embeds this HStack in the VStack. And sometimes you don't know where this, for example, where does this bracket end? I don't know, right? So sometimes if you want to figure out where these brackets kind of end, you can just double click on a bracket and it will highlight the corresponding bracket. So this is a very good way to kind of, if you're kind of lost. All right. So on this VStack, let's create this stuff here. So I have this text. Um, let's do another text here. This is Swift. This is bold. This is font title. Text, the Swift programming language. And then here, for this right here, I have an H stack, right? Um, now, there's some, Apple gives you a suite of icons for you to use for free, and they are called SF symbols. You could go to the Apple developer website and you could download this app called SF Symbols. Um, SF Symbols. And it's an app where you could browse through all of different font, I guess, icons that you could use within your app. Okay. And I want this link icon. So I just search up link and there it is. And I just basically copy the name, go back to my Xcode. I use the image system name variant and I basically pass in that the SS symbol name, and there I go. There I have my link icon there. All right, so I'm gonna make this foreground style.gray, and then within this thing here we have another text swift.org, and then I'll make this you can see it's kind of the font weight is a bit bolder, so I'll use this font weight modifier with the medium font weight to make it a bit more bolder. All right, so now you can see we have our thing, but right now it's kind of everything is aligned centered, right? We want to align things to the left. So on this VStack, we use the alignment and we can use the leading to align everything to the left. Now, why is it not left and right? Well, in other languages, like for example, Arabic, Hebrew, it's not left to right, it's right to left. So Apple kind of makes it more um uh basically leading for a language is basically start direction. So if the user selects Arabic within your app, the leading is now the right. But for English in many other languages, it's the left. Okay. Now if I change this to trailing, boom, everything gets shifted to the right. Okay, cool. Now, as you build your app, things get very cluttered, right? This is a very simple UI, but it's already getting a bit claustrophobic. So how I like to do things is that I like to get everything into variables. So what I'm gonna do is that I'm gonna make this into a variable. So I'm gonna cut this out. And then after the view body right here, I'm gonna create a variable. I'm gonna make this private because no other view needs to access it. I'm gonna call this my logo header view. And then the type of this thing is a sum view because, well, there's many views I could put here. You could put a text, you could put an image, you could put a button. So we need this sum view just to tell Swift saying, hey, it could be any kind of view. But don't worry about the semantics of it. So we have this variable here. Now I can use it above here. So I can use logo header view like that. And it should show above like that. Awesome. Okay. Um, just to quickly, I don't know, running out of time just a little bit. But I want to kind of quickly show how we can create these two things right here. Okay. I'm going to create a new view called, this is again, an entirely new view called a repo stat view. Okay. And then within this new view, it takes in a system name. It takes in a stat number, and it takes in a stat name. Okay. And within this body, I have an H stack of spacing 3, image system name. We'll pass in that system name that we got. So okay, these are parameters that we're passing into this view that we can use within our body. Font weight medium. Text stat number, font weight medium, let's see, foreground style dot black, text dot stat name. And what we have done here is that we create this new view. This is our custom view, right? And we could reuse it. So what I would, so to create this right here, I would basically, here I'll create a H stack, with spacing 10. And then here for this stars right here, I do repo stat view. What's the system name? It's a star. The stat number is 67 point. Okay, now it's updated. Before it was this. Stars. And then I can reuse this component to do the other forks here. So this one right here is arrow, triangle, branch. This is 10.3, and this is forks. So as you can see, I can create my own custom views, pass data into them, and I can reuse them as many times as I want. Okay. So if you ever find yourself kind of doing a lot of repetitive work, put it into your own custom view and then reuse it. Okay. Time is running out. Don't worry about attendance. I'll just we'll just wave it again. It's fine. Okay. Yeah, that's about it. I will post the whole code on the website so you could go through it. But yeah, that's about it. Thank you guys for coming. If you guys have any questions, to stay for office hours and yeah. All right.